Alright guys, so Miss Murphy here. Again, I'm very sorry that I'm not here today. I am sick and I went to the doctor and they said I should stay out one more day. I promise I'll be here Wednesday. But anyway, I don't want to skip behind in the notes. So you should have gotten the new packet from Miss Phillips. This unit is all about congruent triangles. Now, before we can get into the congruent triangle theorems and all that stuff, we need to review some of the angle stuff. Some of the angle theorems that you should already know, as well as some of the triangle theorems that you should, for the most part, already know. Now, some of this connects back to that delta math that I had you guys do last week that was due last night by midnight. So if some of this looks familiar to you, that's why. That also means that with some of the examples, we are going to blow through some of the easier examples and just not do them because, again, that was typically what that delta math was. So yeah. All right. So let's first just start with the vocab review. So first off, angles is formed by two connecting rays that share the same endpoint. So, for example, if I was to draw a picture of it, all right, this would be the vertex. This would be the ray itself. This would be the other ray. And this right here denotes where the angle is. All right. Now, vertex, again, is the common endpoint shared by two rays to form the angle. So it's the endpoint that those two rays share, and through that connection, the angle is formed. Now, straight angle, you've probably heard about this back in middle school, but a straight angle is 180 degrees. So a straight angle is literally just a straight line. So if those rays laid flat in a straight line, it would measure 180 degrees. Congruent angles are angles that have the same measurement An angle bisector is a ray, segment, or line that divides an angle into two congruent angles. So, for example, if I were to draw a quick picture of it, let's say I had an angle, and then I have, let's just say, a ray right here. So whatever this angle was originally, let's just say it was 60 degrees. So let's say the green angle measure, like the whole angle is 60 degrees. That means that the little mini angles formed here would each be 30 degrees. It literally cuts it in half. Adjacent angles are two angles that lie in the same plane that have a common ray and a common vertex. A lot of times we call that ray the common side. So if we have adjacent angles, looks something like this. So this angle is adjacent to this angle. Now the reason I use two dashes here versus one is to show that they are not congruent. Now, could some adjacent angles be congruent? Yes. Is that always the case? No. Vertical angles are two non-adjacent angles, meaning they only non-adjacent angles, meaning they don't have a shared side, and they're formed by two intersecting lines. Now, like I was saying, vertex angles share a vertex, but not a ray. That's why they're called non-adjacent. So even though they have the same vertex, they do not share one of the rays. Now, I like to say that they look like vertical angles look like X's. So for example, these two angles right here would be vertical angles. These two angles right here would also be vertical angles. And vertical angles are congruent. So if you have two pairs of vertical angles or a set of vertical angles, those two angles are congruent. Now, a linear pair is a pair of adjacent angles, meaning they share a side or a ray and a vertex, whose non-common sides are opposite rays. Now, biggest thing about an adjacent angle is that they form 180 degrees. You could also say that they're supplementary, same thing, they add up to 180. So an example would look something like this. All right. This angle measure and these two angle measures, they are not congruent necessarily, but they will add up to 180. Now, the last two you should definitely already know. Complementary angles is just two angles whose sum add up to 90 degrees. Supplementary are just two angles whose sum add up to 180 degrees. You guys have most likely already learned that back in middle school. Now, another theorem that you guys should, for the most part, already know is the triangle sum theorem. And the triangle sum theorem is very, very straightforward. All it is the sum of all interior angles, or the angles inside the triangle, of a triangle equals 180 degrees. All right, so if you just had a triangle here, let's call this angle X, this angle Y, and this angle Z. They're not necessarily congruent to each other, they're just different angle measures. That means X plus Y plus Z is equal to 180 degrees. Now, you guys have probably already seen this within your delta math. So basically, if they ask you to find a missing angle within the triangle and they gave you two of them, you just add them together, subtract them from 180. All right, so let's do an example or two together. So I'm going to pick and choose some of the ones that I believe are harder, and then whatever's left, I would like you guys to try on your own for homework. All right, so I'm on page 3 now. So I'm going to do the top right example first. All right, so it's asking us to find the missing angle marked by the question mark. So we're finding this angle right here. Now, they gave us an angle inside, which is that 100 degrees, but they also gave us this angle right here, which is 35 degrees. All right, so where you would want to start is that if you notice, one of the angles inside the triangle with the 35-degree angle are vertical angles. Thus, we can assume, since vertical angles are congruent, that this angle right here is 35 degrees. Now we can use the triangle sum theorem to find this angle right here. So we're using TST, or the triangle sum theorem. So you just add 35 degrees plus 100 degrees plus, let's call that angle X, plus X is equal to 180. This would be 135 degrees plus X is equal to 180 degrees. And then if you just subtract 180 and 135, X should be 45 degrees. All right, so this angle right here is 45 degrees. Now, to find the angle that we're trying to find, so let's call that angle Y. If you notice, these two angles right here, the orange and the green, are a linear pair because they're on that straight line. They're adjacent to each other. So we can assume And since it's a linear pair, they should also add up to 180. So I have 45 plus y is equal to 180. Subtract 45 from both sides, you should get y equals 135 degrees. And that's what this angle right here would be. All right, so sometimes these are kind of a map that you kind of have to work your way around to get to your answer. All right. All right. So the rest of these examples for part 1 you should be able to do on your own. Most of them are simply just the triangle sum theorem, and then the one on the bottom right, so this one right here, that's very similar to the example that we just did. All right. Now, I'm then going to do part 2, which is where we're solving for x. So I'm going to do one of these, and the other example is yours. So whenever you're solving for x, so we're solving for this x right here in this expression, you're basically going to use the triangle sum theorem to help you accomplish that. So you're basically going to take all 3 of these angles, add them up, set it equal to 180, and then use inverse operations to solve for x. So I have 55 degrees plus 54 degrees plus x plus 74 is equal to 180. I'll combine like terms, so add the 55, 54, and 74, so this will be 183 plus x is equal to 180. And then if I subtract the 183 from the 180, x is equal to -3. Now, since it only asked us to solve for x, we're going to stop there. Now, if it asked you to find that angle measure, you would plug the -3 back in for the x to get that missing angle measure. All right, but since they only asked us to solve for x, we're going to stop there. All right, so that other example, try on your own. Now, for part 3, it's asking us to find the measure of angle A. So I'm going to do this right example right here, just because it looks a little funky and I just want to make sure you guys know what's going on. So we're finding angle A, which is this angle right here. And just so you know that this expression is connected to that angle. Now, we also got another expression right here with the 4x plus 17. So we have the 2 expressions on the inside and then one on the outside. But if you notice, these are once again vertical angles. All right. So we can assume that if this angle is 4x plus 17, this angle is also 4x plus 17. So we now got enough information to use the triangle sum theorem by adding up all 3 of those expressions and then set it equal to 180. So I would have x plus 23 plus 4x plus 17 plus 80 is equal to 180. Now, I'm going to combine like terms, so the x plus 4x is 5x. 23 plus 17 plus 80 is 120, is equal to 180. Subtract the 120 from both sides, I'll get 5x is equal to 60. Divide both sides by 5, x is equal to 12. Now, we're not done because it asked us to find the measure of angle A. All we did right now is solve for x. So I'm going to take this 12 and plug it back in for the expression for angle A. So angle A would be equal to 12 plus 23, which would be 35 degrees. So angle A is equal to 35 degrees. All right, so try that other one on your own. All right. On the next page, there's 2 more examples that are very similar to what we just did. I also want you guys to try those on your own. You're still solving for angle A. Now, The next theorem you may or may not already know. I assume you may know it already. It's not a very hard theorem. It's called the exterior angle theorem, which just means that an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So that's a mouthful, but if I drew a picture of it, I'll have some straight line with a triangle drawn on top. And then I'll have, let's say, X, Y, and angle Z's over here. So what it's saying is that we add up angle X and Y, it would equal to angle Z. All right, that's the exterior angle theorem. So if we add up these two angles that are not connected or adjacent to angle Z in any way, it should equal the measure of angle Z. Another thing to note with exterior angle theorem is that typically if you have an exterior angle out here, more often than not, the angle that's adjacent to it is a linear pair. So that's another way you can think about it. All right. So I'm going to do some quick examples for all of these. All right. So first I'm going to do number 1. So it's asking us to find the exterior angle right here. Let's call it X. So what you're going to do is the two angles that are not connected or adjacent to that angle X, so it'd be 105 and 35, all you're going to do is add them together to give you X. So if you add them together, X is 140 degrees. So that means this angle right here is 140 degrees. Now, if you wanted to go a step further to find out what this little angle is, well, all interior angles got to add up to 180, and this right here is also a linear pair. So either way, you should get, if you subtract it from 180, so 140 from 180, you should get 80 degrees. Now, they didn't ask you that, but that's just something that you may want to know because you may run into it later on. All right. Number 3 is the last one I'll do for this section. And then the rest of it, I'm going to ask you guys to do on your own. All right. So with number 3, it's asking us to solve for X. So they gave us the exterior angle here, and they gave us the two non-adjacent angles here. So how we're going to set this up is we have 13x minus 4, so that's our exterior angle, will be equal to the sum of our two interior angles that are non-adjacent to the exterior. So we'll add these together. So 6x plus 2 plus 50. And then we're just going to solve for x. So if I combine like terms first, I get 13x minus 4 is equal to 6x plus 52. I'm going to subtract the 6x to the other side. So I get 7x minus 4 is equal to 52. Add the 4 to the other side. 7x is equal to 56. And then divide by 7, x will be equal to 8. And then remember, if they ever want you to find the angle measure of either angle WUV or angle FWV, so again, that would be either this angle or this angle, all you do is take that 8 and plug it back in for x, and then evaluate it. All right, so this ends lesson 2.1. So you do have a delta math on this. It'll be delta math 2.1. That will be your main homework. But I also want you guys to try some of the other problems that we did not already do. All right, so between pages 3 and 4, try any of the problems that we did not already do in this video. I'm not necessarily taking it for a grade, it's just extra practice. And I will post the full key in Canvas in the new module. All right, and that's it.